Ever pondered about how different types of networks function? Imagine a bustling city with roads interconnecting various destinations. In the digital realm, networks function in a similar fashion, linking devices and systems, facilitating communication and data exchange. They're the unsung heroes that keep our digital lives humming along smoothly. Now, networks come in an array of types, each with its unique characteristics and applications. In this video, we're going to explore the Virtual Local Area Network, or VLAN, the Wireless Local Network, or WLAN, the Metropolitan Area Network, or MAN, the Wide Area Network, or WAN, and the Virtual Private Network, or VPN. We'll also tackle what it means when we say local area network to this world, and we'll demystify the roles of a hub, repeater, and switch. Finally, we'll delve into the various types of wireless networks. Stay tuned as we delve into the fascinating world of networks. First off, let's explore the realm of virtual local area networks, or VLANs. A VLAN is a network within a network, a subnetwork if you will. It's a clever solution that allows a network administrator to partition a single physical network into several smaller logical networks. Each VLAN operates independently from the others, almost as if it were its own separate physical network. So why would we need VLANs? The answer is simple: flexibility, efficiency, and security. VLANs can group together devices that are geographically scattered, but need to communicate as if they were on the same physical network. This way, data traffic is efficiently managed, and network performance is improved. Furthermore, because each VLAN is separate, data can't move directly between them, adding an extra layer of security to the network. In essence, VLANs offer flexibility, efficiency, and security in networking. It's like having your own private rooms within a massive mansion, each with its own rules and decor. Next up, we have Wireless Local Network, commonly referred to as WLAN. A WLAN is essentially a local network, quite like the ones we discussed earlier, but without the restrictions of wires. Instead, it uses radio waves to transmit data over short distances, typically within a building or a small group of buildings. This technology brings about a significant level of convenience and mobility. You can move around with your device within the network range and still stay connected. WLANs are widely used in homes, offices, and public places like cafes and airports, offering internet access to multiple devices simultaneously. One of the main advantages is cost efficiency, as it eliminates the need for expensive cabling. However, do keep in mind that while WLANs offer great convenience, they may not provide the same level of performance as wired networks, especially in situations requiring high data transfer speeds. Clearly, WLANs provide convenience and mobility in networking. Moving on, let's look at Metropolitan Area Networks, or MANs. A metropolitan area network is a larger network that typically spans several buildings in the same city or town. They are designed to extend over a larger geographical area than a local area network, or LAN, but smaller than a wide area network, or WAN. MANs are primarily used to connect multiple LANs together, allowing communication between different networks. They can be found in settings such as a large university campus, a city's business district, or even a whole city's infrastructure network. Key features of a MAN include its ability to support both data and voice communication, its high speed, and its capability to handle a large volume of data. They also provide a level of security and control, as they are often owned and managed by a single entity. So, MANs effectively bridge the gap between local and wide area networks. Now, let's turn our attention to wide area networks, or WANs. Imagine an expansive network that stretches across cities, countries, or even the globe. That's what we call a wide area network. Its primary function is to allow data and information to travel vast distances, connecting local networks from different locations. A typical use of WANs is within large corporations or organizations, allowing them to link their local networks across multiple sites. This enables employees, wherever they are, to access and share resources as if they were sitting in the same office. Key features of a WAN include its vast geographical coverage and the use of leased telecommunication lines or satellite links. A WAN can be privately owned or rented, but more often than not it's a shared resource, making it cost-effective. In a nutshell, WANs enable long-distance communication and data sharing. They are the highways of our digital world, paving the way for global connectivity. Up next, we have virtual private networks, or VPNs. Picture this. VPNs are like private tunnels in the vast expanse of the internet. They allow your data to travel securely from one point to another, away from prying eyes. They serve a dual purpose, enhancing security and ensuring privacy. When you use a VPN, your data is encrypted, making it unreadable to anyone who might intercept it. This is particularly beneficial when using public Wi-Fi networks, which are often not secure. But VPNs aren't just about security, they also provide privacy by masking your internet protocol or IP address. This makes your online activities virtually untraceable, keeping your browsing habits safe from advertisers and other third parties. Furthermore, VPNs can bypass geographic restrictions on websites or streaming audio and video. So whether you're a globetrotter or a homebody, a VPN ensures your online world is both private and unrestricted. Hence, VPNs provide secure remote access to network resources. Let's now talk about how LANs connect to the world. To expand beyond the local, LANs need a gateway to the wider world. This is where routers come into play. Acting like a postmaster, a router directs the flow of data between networks, ensuring that your email or your latest Instagram post reaches its destination. However, it's not just routers doing all the work. Internet service providers, or ISPs, also play a crucial role. ISPs offer the pathways that connect your LAN to the internet. Just think of them as the highways your data travels on. So, routers direct your data, ISPs provide the roads, and together, they connect your LAN to the World Wide Web. In essence, they transform your local area network into a global communication tool, allowing you to interact with millions of other networks around the world. So that's how our local networks become a part of the global internet. Let's now understand the role of hubs, repeaters, and switches in networking. A hub is a simple device that connects multiple devices together and forwards any data it receives to all its ports. It's like a big room where everyone hears everything. A repeater, on the other hand, is a device that amplifies or regenerates the signal to extend the reach of a network. Think of it as a loudspeaker, amplifying the voice so it can be heard at a distance. Finally, a switch is a more intelligent device that can direct data to a specific device on the network, rather than broadcasting to all connected devices. It's like a postman who knows exactly where to deliver each letter. The key difference among these three lies in their function and intelligence level, with the switch being the most intelligent. So, hubs, repeaters, and switches play crucial roles in managing network traffic. Finally, let's look at the different types of wireless networks. The first on the list is Wi-Fi, a popular choice for home and office networks. Wi-Fi allows devices within a certain radius to connect to the internet or each other, creating a local network with no wires needed. Next up is Bluetooth, a short-range wireless communication technology. It's perfect for connecting devices that are close together, like a smartphone with a wireless headset or a laptop with a wireless mouse. Now, let's talk about cellular networks, which are the backbone of your mobile phone's internet connectivity. Cellular networks cover a wide area and rely on multiple signal towers to ensure a seamless internet experience, whether you're at home, in the office, or on the move. And those are just a few examples. From Zigbee used in home automation to satellite networks that cover even the most remote parts of the world, the possibilities are endless. Indeed, wireless networks have revolutionized how we communicate and share data. So that was a quick tour of different types of networks. We've traveled from the intricacies of virtual local area networks, or VLANs, which allow for partitioning of a physical network into smaller logical networks, to the convenience of wireless local networks, or WLANs, that keep us connected without the need for physical cables. We've journeyed through metropolitan area networks, or MANs, connecting cities and towns, and wide area networks, or WANs, bridging geographical gaps on a much larger scale. We've delved into the security and privacy offered by virtual private networks, or VPNs, and the role of LAN in connecting local devices. And let's not forget our exploration of the key devices that make these networks possible: hubs, repeaters, and switches, each with their unique functions. Finally, we skimmed through the various types of wireless networks that are becoming increasingly prevalent in our daily lives. We hope you've gained some valuable insights into the fascinating world of networks. Until next time, keep exploring.